day there was always a choice about what you were going to go see. So I was pretty selective. I went to some just kind of like high-level things. I didn't go to a lot of the oral presentations. So those of you who did attend the sessions, that would be great if you could chime in. But specifically, I was there to support the Arctic Report Card rollout. So this is an annual publication that NOAA supports that looks at the last year's observations of the Arctic, specifically sea surface temperature, air temperature, tundra greenness, which might be of interest to you guys, and a variety of other topics. This year, we had an emphasis on a guest essay from the Bering Sea Elders group. So they gave their indigenous perspective on the changes in the Bering Sea region, and it was absolutely captivating. During the press panel, which is where we do the official rollout, there were about 120 people in the room. It was standing room only. Admiral Gaudet from NOAA gave the opening remarks. We had 3 panelists, Matthew Druckenmiller, Don Perovich, and Melissa Johnson from the Bering Sea Elders Group, who each gave about 5 or 10 minutes comments, and then we opened it up for questions. The press panel, which is normally scheduled for 45 minutes, and that's usually a pretty strict cutoff point, they were allowed to go for about an hour because people were just fascinated by what Melissa was talking about on behalf of the elders. So I'm going to throw a link in the chat, and you can go see the full report if you're interested. Oh, that didn't actually become a link, but that'll take you to it. So that was on Tuesday. Let's see, Wednesday there was the IARPC town hall in the evening, and we had, who was it, Colleen, Martin, Caitlin, Mike was sitting up there. I can't remember if there was anyone else, Sarah, but that was a really fascinating, Renew was up there, yep. That was a really fascinating interaction, and I think it was a really good town hall. There was a lot of back and forth. And I particularly came away with how kind of eager early career people are interested in engaging with IARPC and with the agencies. So I think we got an idea for how the new early career team could go forward in learning how to engage with each of the agencies. So if you're interested in that effort, please reach out and we'll get you on the schedule for that. I'm going to talk about there was a town hall on Thursday called Voices from the Bering Strait. So that was related to the Bering Sea Elders' contribution to the Arctic Report Card. This was a town hall hosted by Rachel Daniel from the Pew Institute. We were supposed to have a panel of quite a few different elders, but travel from Alaska created a couple of mishaps. So we ended up having Melissa Johnson from the Bering Sea Elders Group, Jerry Ivanoff, one of the Bering Sea Elders, and his family were able to attend. And then Julie Raymond Yakubian was also there to provide a little bit of support. So essentially, they came in and talked about, expounded upon a little bit further about what they were seeing in the Bering. Jerry gave this really kind of like eloquent speech that was super moving about how the changes that have been happening with decreased sea ice and less snowfall, and how that's just creating a lot of hardships for the communities that live up there. Julie got up and spoke about how we almost have a moral necessity to do relevant work for communities in that area. One quote that I wrote down from Jerry is that he said that, when he's out in the forest or when he's out on the ice, he says that, he's a weatherman, he has to be a botanist, he's an ornithologist, he has to be able to study the birds, he's a marine biologist, has to be able to determine whether or not the seals that they catch are fit for consumption. So what really came across to me was that the indigenous people in the area have a lot of knowledge, and we really need to do better about engaging with them. They opened the session with this great video that talks about the Bering Sea Elders' contribution to the Bering Report Card, the Arctic Report Card. that was funded through Search. So I encourage you to check that out. It's a really well done video and really gives you a sense of the community up there. Sarah, I don't know if you wanted to mention the IARPC listening session.
Sure, I can just mention that the IARPC principals approved the development of the next Arctic research plan, which we're going to take 2 years, which I know sounds like a long time, but we're hoping to have a really robust involvement from communities, from the research community, from Indigenous communities, state, industry. And so we're going to take the first 6 to 7 months for that engagement process. So at AGU, we held a listening session that I think about 20 people attended. And we got some really good suggestions about ideas and thinking about what the framework and scope of the next plan should be. So they'll go into a database that we're keeping as we do these types of outreach. And we'll be using the collaboration teams to help us with that activity as well. So there will be an opportunity for you to engage when this team has a discussion about that.
Yeah, and the only other thing I was going to mention is that IASC also held a side meeting to talk about their upcoming activities, specifically ASSW, which the early bird registration for that ends on January 8th. And then that also includes the Arctic Observing Summit, which, Sandy, I know you're sick, but if you want to say anything about that, I'll give you an opening.
Yeah, I will say a few words. Thanks, Kelley. So the Arctic Observing Summit, this is going to be, I believe, the 5th summit. We have, as the observing team, convened discussions to support the just kind of awareness and outreach around the event, but also to help people collaborate better on their white papers and short statements. The call for white papers and short statements did just close. And the working teams are starting to consolidate and line up behind the white papers that they're going to review. So that's sort of the status on the summit. This year is very much going to be about kind of developing more well-defined support for what's known as the ROADS process, which is the SAON road mapping process, which relates to requirements and implementation strategies, such as what I described earlier. So I would really encourage folks on the call to think about attending if you're not planning to.
Awesome. Was there anyone else from AGU who wanted to chime in on anything they saw?
This is Mike. I can just say a couple of things. The weekend before AGU, I went to the Arctic-NG meeting, which was also in San Francisco. And so that was my first exposure to that group of people. It was really interesting. And so in addition to all the scientists and science team leads from Arctic-NG, Dan Stover, of course, was there. I was there. Renew was there. And there was a lot of planning, a lot of scientific presentations, some really good speed talks by students, and some breakout groups. And one of the breakout groups was discussing what happens beyond phase 3 of Arctic-NG, and so they're starting to think into the future there. We had a big session at AGU. We called it the Above session because it was planned by above science team people, but it was really focused on, it was more than above. The title of the session was Resilience and Vulnerability of Arctic and Boreal Ecosystems to Climate Change. And I think it was one of the biggest sessions at AGU. So we had 5 orals, 1 regular poster, and then 1 e-lightning session. And the oral session was just always full of people. So that was a lot of great stuff there. And the only other town hall that I was at that's of IARPC interest potentially would be the ISAT-2 town hall, which was led by the ISAT-2 science team, and they had a maybe a 20 or 30 minute presentation where different science team members that are using ISAT-2 data for different applications, like for sea ice, for land ice, for vegetation, for atmospheric property or characterization of atmospheric properties such as clouds. They all gave little presentations, and then a lot of good feedback from the audience. It seems like everybody is very happy with the data that's coming down from ISAT-2 for all those applications.
And if there's anyone else who wants to jump in and share about AGU, now's the time.
Well, hi, this is Randy. I'll say, I'll just add one thing. We had a meeting of opportunity at AGU. We've been starting to think about how to use a lot of this great data and findings coming out of the Above Science program and apply them to stakeholders' needs in Alaska. And we work primarily with fire management agencies and land management agencies and native organizations that are involved with resource management. And so we had a little planning workshop, and we are actually looking at having a mini workshop after the Above Science meeting in May this year as a follow-on. So it'll be the afternoon of the 14th and the 15th at UAF after the Above Science meeting. And we're going to focus on some of the high priority science coming out of above and a couple other places that look like they have a great path to a research to operations path for use in Alaska, focusing on vegetation, soil moisture and fuel moisture, fire effects, and overwintering fires. So I just wanted to get the first word out and maybe hold the date on that, because I know we'll hope to see a few of you be able to make it to that workshop. It'd be really great. Thanks.
Great, thank you. And yeah, are there any other comments? And I will be putting that on my calendar. I don't know if it would make sense for IARPC to participate in some way. It's maybe, Mike, if you'll be there, getting some input somehow on how that might connect with what should be going on the next plan might be good, but we'll connect on that.
Yeah, let's talk about that. I think it would be good to, I will certainly be there, but it would be good to get broader participation as well if possible.
Okay. Okay, and I think we're ready to move on to the next part of the agenda then.
Okay, is that, I don't have the agenda up. Is that the presentation by Lesley and Bryan?
Yes, it is, and I'll just go ahead and share that agenda here.
Okay, well, so I'll go ahead and introduce both Lesley and Bryan, and then talk just briefly about how this came about. So Lesley Ott is a research physical scientist in NASA's Global Modeling and Assimilation Office, otherwise known as GMAO, and she has a background in meteorology. Lesley leads the carbon modeling group in GMAO, which seeks to integrate land, ocean, and atmospheric models to better understand carbon cycling and the constraints imposed by various satellites observations. She's a member of multiple NASA science teams, including the Orbiting Carbon Observatory, the Carbon Monitoring System, and of course above. Bryan Duncan is a research physical scientist, also at NASA Goddard. He's in the Atmospheric Chemistry and Dynamics Laboratory. He's the project scientist of the NASA AURA satellite mission, which observes some atmospheric trace gases relevant to tropospheric composition, monitoring of the ozone layer, and climate. He also has experience tracking air pollution in the Arctic and simulating methane in atmospheric models. And so today they are going to be presenting a recent publication entitled Space-Based Observations for Understanding Changes in the Arctic-Boreal Zone. And just as a little background, so at every science team meeting that we hold, this includes above and terrestrial ecology, anything that has relevance to research in the Arctic, I usually get up on stage and spend about 10 or 15 minutes talking about IARPC and what it is and what we do and why it's important for PIs, people that we fund and science that we support, to consider presenting their work at IARPC collaboration team meetings. And so a couple of months ago, we were in San Diego at the NASA Carbon Monitoring Science team meeting, and Lesley actually approached me. She must have seen me talk at either the TE science team meeting or the above science team meeting, and said, hey, we got this great paper that's coming out. I would like to see if we can present it at an IARPC collaboration team meeting. And so I said, let's do this. And it was really just a good sort of proof that, you know, people are starting to think in terms of some of our PIs, you know, how they can get this work in front of groups like IARPC. So with that, I will turn it over to Lesley and Bryan.
Thanks, Mike.
Okay, so I'm going to share my screen now. So somebody has to unshare their screen.
I just did, so that capability should come back to you.
Okay.
There you go.
Okay. So let me just skip on. So this resulted from a task group that was formed here at NASA Goddard Space Flight Center called CABS, Changes in the Arctic-Boreal System. And the purpose of this, upper management specifically wanted the different disciplines at Goddard to actually talk to one another and work together. Because everything was very stovepiped. You know, I work in my department, we only work with other people in our department. So this is their way to get us to work together on a very important issue. Because we have a lot of expertise here at Goddard to bring to this issue. So you know this, I'll skip this. But I wanted to say this is a very text-heavy presentation and it's meant to be standalone, so you can read it at your leisure. But we figured that we put everything in there, just so in case somebody wanted to read this later since you're posting it. So the Arctic is complex. You need to think about it in a process-based, interdisciplinary way. So back in, I think CABS was formed in 2014 or so.
Yeah.
And I became involved in 2015, even though I had almost no Arctic expertise. But of course, my background is primarily air pollution, and air pollution does affect the Arctic. We had a NASA field campaign called ARCTAS in 2008. I was involved in that. I was up in Fairbanks. Okay, so somebody had the idea, maybe it was me, I don't know, about putting together a review article, and it was to, from a NASA perspective, on the current observing capabilities of the Arctic Boreal Zone, and then to make recommendations on improving this observing strategy and making it more comprehensive. So we had quite a few different motives for doing this. We were wanting to beef up our expertise at Goddard, so this would help us to identify strategic hires, and also to form collaborations with outside of GSFC. And you know, everything about NASA is about satellites, putting hunks of metal into space, so this would inform mission development. And it would also allow better support of model development here. So Lesley's part of the GMAO, the Global Modeling and Assimilation Office, that has a suite of Earth system models. And also, we were hoping to better inform people on how to properly use satellite data for Arctic research and policy decision-making. And you've already heard about above, and there are many Arctic observations taken by NASA satellites. But we really still, as far as I'm aware, maybe Mike can correct me, there isn't a real strong interdisciplinary effort going on at NASA on the Arctic Boreal Zone. I'll skip the terminology, but in our paper, we specifically use phrases in different ways. One thing that we wanted to point out is the hardest part of a review article and making recommendations is getting a consensus. So there were over 40 people involved and 40 strong personalities, and we all had to come to a consensus on what we were going to recommend. And so Lesley and I really learned a lot from being on the National Academy's, it's called the Decadal Survey, where every 10 years the scientific community basically informs NASA what are the relevant science issues of today, and so that we can develop satellites. So we were on that committee, one of the few NASA folks, and we learned a lot about the consensus process. And so we actually, this text here is what we wrote to the editor of the paper saying, yeah, we really realize this is a contentious issue, but we did come to a consensus. So it finally was accepted in October. This was several years in the making. I think we had 7 different reviews, and I'm talking like 30 or 40 pages of reviews. It was really a big deal. And so I just submitted the copy edited version today. And it's actually 95 pages without the references. And it's in a very small font size. So it's a big paper. It really only has NASA personnel that are represented from government agencies, I mean. So it's not an interagency type of paper that we put together here. But we definitely would be interested in working with other agencies going forward. And we did have scientists outside of NASA from the US, Finland, and Canada. Okay, so you can't read this table of contents, but we had many different contributions from different people in different sections on different topics. And we focused everything, how do I get rid of that? How about that? Okay, there, okay. So we focused everything around 5 questions, every section around 5 questions. Why is observing that ABZ variable important? Maybe that might be sea ice. And so we talk about what the suborbital, and if you're not a NASA employee, that's NASA speak for anything but satellites. So anything below, within the atmosphere or at the surface. So what suborbital observations do we have of the historical state of this variable? And then we move on to satellites. What is the historical and current state of satellite observations of that variable? And then we move on to what important properties are we currently missing? So we're trying to identify what we need to add to the observing network. And then we list our recommendations for going forward, and not just for the orbital, but also the suborbital component, because speaking just from a NASA perspective is we do need surface observations to help us interpret the satellite data and evaluate it. And we decided to not have weather forecasting in this because that's just a whole nother topic that could be another paper.
We aim to be as complete as possible. Weather forecasting was one thing that we thought could just become its own issue. And then also, we don't really get into a lot of modeling needs, again, because that could be easily its own 100 pages. So it's really focused on the observations.
Okay, so if you want the whole paper summarized in one slide, here it is. One recommendation that we made is, these long-term satellite data records have been absolutely crucial in understanding Arctic change and monitoring it over time. And so it's very important that these continue. But one thing to remember that maybe some of you don't know is NASA isn't an operational agency. So that's not what we do. For instance, like NOAA is more of an operational agency. In fact, NASA is more about identifying and developing cutting edge research and techniques for new satellites, instruments. So, we need to keep this in mind when approaching NASA personnel, and also when trying to figure out this interagency coordination. One thing that we did recommend that was cutting across several of the disciplines was the need for Lidars, or this is active observation. So they bring their own light source to the Arctic. And I'll go into more reasons of why that's important for a number of disciplines. I've already talked about the need for a coordinated suborbital network for validation and interpretation of the satellite data. And then we, we recommended 2 high priority cycles, the carbon cycle and the hydrologic cycle, because they're important for monitoring and studying and understanding Arctic change, but they have potentially a large societal impact, which elevated their importance. We made 4 general recommendations that cut across all the disciplines. One was the need for Supersight observatories, because maintaining observational networks in the Arctic is very expensive. And so if you have the infrastructure there for one site where all the disciplines can take advantage of it, I think that would go a long way. Other Arctic themed efforts have also identified this need as well. As I said before, we really need to extend these multi-generational data sets. Of course, urgency. Satellites, they just take a long time to develop and to get into the air, and the Arctic is changing rapidly now. So this isn't something we can think about, 20 years down the road. We need to think about it now and act. And then we need to figure out ways to help interpret these observations for policymakers. Okay, so after Lesley and I went through the National Academy's decadal survey, we decided that in the end, the way that they ranked observational priorities for the globe was actually a pretty good way to do it. And here's how we defined our variables. Most important, those are observational needs for which the variable is poorly observed currently, and the current process-based understanding is poor. So within very important would be observational needs where the variable is insufficiently observed and more or better observations are necessary to advance process-based understanding of that variable. And then important, let me note that every recommendation that we make, every variable is important by definition, okay? And so many of our long-term observations, these multi-generational records that we have that have been critical to monitoring the Arctic fall into this important category because we do have those observations, and the current and anticipated future observations of that variable are considered to be adequate. And then, as I mentioned earlier, we really did have one other criteria, and it was the potential to affect large portion of Earth's population. And this would be, for instance, sea level rise or large volumes of carbon being released from Arctic soils to the atmosphere. One specific recommendation that we made was for the carbon cycle, and that's not a surprise. And these included not just observing methane and CO2, for instance, but also all the factors that affect its emission sources, say from wetlands, permafrost thaw, the ocean, and so on. And the same for the hydrologic cycle, really. It's also observing, continuing these passive microwave instruments and developing new technologies to better define the coast and sea ice edge. Then we also recommended better observations for ice and snow albedo and snow water equivalent. And then again, improved observations of wetland and permafrost as discussed in the carbon cycle because they're important components of the hydrologic cycle as well. Again, Lidar. Lidar, to some of you, you may not realize the advantages of it, but okay, yeah, it brings its own light source. It looks down as it's passing over the Arctic, so you don't have to worry about the path that you're looking at. It's much more direct than from passive instruments. It's also a narrow swath, so it can see between clouds, so the Arctic is a cloudy place, so you have more opportunity for observations. And for satellites in polar orbit, they preferentially pass over the Arctic much more than they do the tropics. So even though their swath would be narrower, they actually would have a better revisit time of the Arctic.
And I can give one specific example on LIDARs. One challenge we have in CO2 and methane is right now all of the observations we have are passive, which means we only get observations during part of the year. And so we're missing what might be substantial emissions of particularly methane during seasons that are too dark for the current satellites to see. And so that's one advantage of LIDARs, being able to get year-round coverage so we can really understand the processes better over all seasons.
Oh, and then, okay, so one of the last specific recommendation that we made was really based on pragmatic financial constraints, because we could recommend this incredible, comprehensive ABZ observing network. But I think it's important to really realize that most institutions don't have the money for this. There are other priorities in other parts of the globe as well. So we were recommending to focus initially on observing networks to gain a process-based understanding for individual ABZ components, and then start building on that and heading toward looking at cycles like the carbon cycle or the hydrological cycle. So we're using these as building blocks. And then eventually you can imagine at some point we're actually getting into the realm of an Earth system observing network, where the Arctic observing network would be part of that, a very important part of that. Okay, so I won't, I don't want to go through this entire table one because it's multi-pages, but just so you can look at it through your, on your own time, unless you have specific questions. Maybe you have a variable you would like to look at now. But we had 44 recommendations in this table. 7 were ranked as most important, half of them as very important, and then 15 as important. Just as an example, let's use sea ice here, where we had the first column is the ABZ component, like sea ice, the recommended satellite observations, and sometimes with a little explanation and then the rankings. And then in the significant drivers that affect ABZ component, we wanted to just bring home that there are these interdisciplinary interactions and we need to consider those. So we listed those here. And then we wanted to talk about other observations that are necessary, ancillary data. And these could be satellite data sets or suborbital data sets that are required. Do you have anything else to say about that?
No, I think it's good. I mean, I think it makes sense to not go through this in too much detail, but just show the process. And
so we have all these tables. Like Randy Jand, who's on the call, she was involved in fire regimes here. And then both Lesley, I was involved in the short-lived pollutant concentrations and the greenhouse gases, and Lesley was involved in the greenhouse gases as well. But the two of us actually were involved in the introduction, the conclusions, and overall editing. Okay, so I think we're out of time at this point, but what we really would like to get from you is, now that we're done with the paper and we have a little time to breathe, we would like to think that the next steps going forward, and this is not just internally to NASA, but also, how should we reach out to other organizations such as yourself to act upon our recommendations in the article? What's the best way to do that? So I'll just end there. Let's stop sharing.
Yeah, sure. Okay.
Great, thank you. Does anybody have questions, comments, thoughts?
I got a couple of questions. Just generally, that was really interesting, and it reminds me of some of the things that Sandy's been talking about, and I'm sure she'll get into that. But I just got sort of 2 questions. One general, were there any variables you looked at that you didn't think were important? As I used to say as program officer, the Arctic Observing Network, just because you can observe it doesn't mean you should observe it. Now, you can make arguments that you know, we don't always know the benefit of observing something. One has to only think of the Keeling curve and those early CO2 measurements, but people going, what the hell are you measuring that for? But we're sort of glad we did. On the other hand, the resources are not available to measure everything that every PI would like to measure or everything they'd like to hang on a satellite. So, yeah. I mean, how critical were you of those variables, and were there any that you threw out and didn't tell us about?
Well,
good question.
Yeah, that's actually a good question. I think a lot of this fell out organically because people knew what they thought was important ahead of time. But I will give an example of, you know, my background is primarily air pollution. And so in the air pollution section, it was really kind of hard for me to say that, yeah, maybe it's not absolutely critical that we have observations of every pollutant up there, that even my favorite pollutants. But it was important to focus on aerosols because they have such an important climate impact on the Arctic. So we did focus on that. And we did acknowledge that you could measure other air pollutants. One of the issues with air pollutants in the Arctic is that there aren't many sources up there, right? So they don't play a huge role in the climate other than the aerosols. So, but we do make the point that, okay, well now that's the case, but as the Arctic warms, what's going to happen with all this infrastructure development? You know, mining companies are up there, oil and natural gas exploration. The air pollution may be an issue once we start having shipping lanes develop going through the Arctic Ocean in the summer, because I know that's starting to happen already. So maybe that's a long-winded way to not answer your question, but that's my answer.
Yeah, I would say also that you can kind of read, you know, if you were looking for something, there was an emphasis from individual people on trying to get forward what they thought was important. And so if you see something that's not on the table, that's because that group of 40 people didn't think, you know, that rose to the level of being a very important observable. The distinction that you made earlier about not including weather forecasting, though, is kind of an important one. We were looking at this with the perspective of climate and long-term change. And there are, for example, observations that would be important for weather prediction, things like surface pressure, winds. And so I think that's the main thing, is you can kind of read the table as everything that people thought was important and nothing that's not important, but again, through that climate type of perspective.
So why not climate? I mean, why not weather?
Can you repeat that?
Why not weather?
We just say, so we were saying this, I think maybe before you joined the call, we were trying to, so this already ballooned from something that we had hoped to keep shorter to like 95 pages. So when it got to be, you know, weather, or, you know, intrinsically there's a need to sort of talk about weather observations, but also advances in the modeling and data simulation. And we just felt like that was a place we could draw the line and say, you know, okay, that's probably a separate paper that could be written on prediction and on modeling, and to just really try to focus on the longer term types of observables. But in reality, it's just a judgment call and trying to make things as concise as possible.
Yeah, and I wish you could actually see the typeset version of this in the microscopic size of the print. It's incredible.
Yeah. Yeah.
It's very dense already.
Yeah. And I think, you know, one of the goals in actually presenting this was to show people, one of the reasons we have this table and this sort of summary section is we recognize not everybody's going to go through this whole paper, but, you know, if people have questions or maybe want to learn about one section, they can flip to that. Or if they just want to see what, you know, in a certain discipline, what the overall conclusions were, you can flip to that table at the back, and at least that's somewhat concise. But yeah, that's all it was. Colin was just trying to keep things manageable, which we didn't really succeed in doing, but it's done.
Yeah.
So this is Sandy. Will was correct. I have a extremely high interest in what you guys have done, and a couple follow-up observations and questions. One, I would say, did you submit anything like a short statement or white paper to the Arctic Observing Summit on this?
I do not believe we did that.
No, we didn't do that at all. In fact, we were treating this as a very initial NASA effort and focusing more on NASA. It was more about us, really.
Yeah.
But it grew into something beyond NASA very quickly. But I think we were just really, to be honest, focused on seeing if we were actually going to get this published in the end.
Yeah.
Because it did take several years to go through several, 7 reviewers and so on. It wasn't something that happened just in a few months. It took several years.
Yeah.
So what I would strongly encourage, even though the deadline has passed, if you would be willing, is to write a short statement to the Arctic Observing Summit. It's only an 800-word limit on the statement, so it's effectively like a large abstract. To include this in consideration, one of the working groups is working on assessment strategies for the observing system, and what we're certainly collectively working on at the SAON level is to develop a systems level view of the kinds of findings you had, so that we can begin to piece together the whole picture. And this would be an extremely valuable input, both from the standpoint of the findings, but also from the methodologies. Because as we're trying to onboard more communities, we want to have kind of a community of practice around the methodologies for doing this kind of assessment. So that's a comment of encouragement, and I would be happy to just follow up this meeting by sending an introduction to the people who are collecting the short statements, along with a rationale for maybe submitting a late one. I know you guys have been doing a lot of writing, so.
We can do that. We can, 800 words we can do.
Yeah, we can do 800 words. Don't worry about it.
That's doable. Okay, good. And then I guess on context, I maybe wasn't focused enough at the beginning of the descriptions. Were you just looking at spaceborne? Like in your recommendations, to what extent did you talk about what's needed for the in situ? And then also in the definition of sort of the scope, it seems like you're including marine and terrestrial. And I guess in my head, I had just thought this was so related to above, it would just be related to the terrestrial. But is it true that you included both things that might be of consideration to the central Arctic Ocean as well as terrestrial?
We meant this to be interdisciplinary. So, we could talk to the ocean folks who participate and see what they say.
Yeah. Yeah, but we have sections on state of the, believe we have state of the ocean. We have ocean biogeochemistry. So we did try to reach across not just terrestrial, but marine, atmospheric. So we did try to, as best we could, make this broad. And then the other question I think you had was the suborbital and the extent to which in situ is covered.
Yeah, so we didn't make the recommendation for this comprehensive, what we call suborbital observing network, but we did it from the perspective, the recommendations we made were the perspective of satellites, from the perspective of validating the satellites and interpreting the satellite data. So we didn't necessarily claim to be making recommendations for a comprehensive observing network, surface network.
Yeah, but I think there is that thread throughout of sort of the need for satellite data sets to be placed in the context of in situ measurements. And that's even, I think, called out specifically in the table. So even in a concise way of going through of, okay, a certain observable, what are the other pieces we need? We know we can't and shouldn't do everything from satellite. And so what are some of the other pieces? So I would say there's some of that flavor. I would say it's not complete and you would need other people to weigh in, but certainly it's, it runs throughout the paper.
It's definitely a very good start that I think somebody could build on.
Yeah.
To make sure it becomes comprehensive.
Yeah.
Great, thank you.
No, thank you.
I have a comment, if I might. This is Randy. I want to really extend my appreciation to you, Bryan and Lesley, for seeing this project through. You must feel like you just completed a PhD thesis. But I think there's a couple of reasons I think this work is really valuable. One is that I was surprised at, when I sort of looked through it, how cross-cutting a lot of these things are, and just to have them all in one place and just kind of compare them together. So for example, you know, the wildfire, Arctic observing wildfire is directly tied into snow cover observations for the spring fire indices, and it's directly tied into the thermokarst for how that's going to affect drainage and future fire, and it's directly tied into post-fire effects for thermokarst. And just everything is like this ecosystem that's tied together. So I thought that was a very useful aspect of this type of a review. And the second thing is that in some of these chapters, I think it's really cool how it's laid out where we've come from, especially for a NASA outsider like me, just a field person, how far we've come with some of these disciplines and the ability to observe things that we may have suspected from anecdotal observations, but we never really had a technology to prove these things before. And that's what's really opening up for Arctic observation right now. And it makes it really exciting because now we actually have the ability to start to put numbers on things and see, yeah, well, okay, there's a trend, but how fast is it? But now we can start to put numbers in there. And that is what stakeholders need to take action. So I just want to congratulate you again for seeing this through and appreciate all the work you've done.
Well, and thanks for your contribution as well.
I've got one more question. You mentioned just briefly that you had recommended the development of a Supersight for observations.
Mm-hmm.
Did you have, I mean, that's as you mentioned, that's a common recommendation from observers. Do you have any idea what that would look like? Did you come up with any consensus on where it might be? How might you go about doing that? Any thoughts on that?
Good question.
Since I don't have any, I'll pass the buck to Lesley.
No, I don't think I don't think we got that specific, and I think really you could do a lot more specific scoping of what that should look like, where an optimal location would be for different types of observations. We really didn't get into it. It was more just a recurring theme of the need for ground-based observations, but the challenges of working in the Arctic, the challenges of getting power and getting people in and out safely. And so it was this theme of, you know, hey, we need this, but really not getting into that kind of detail about location and what it should measure. But I agree, that's a really great next step that has to be taken.
Yeah. Well, I mean, there certainly are ground-based observations and satellite observations at Summit, for example.
Right.
You know, is that a place? I understand you didn't address that, but I'm just curious. Is that a place which you could see a lot of this work could be done, at least for snow and ice and glaciers, or do you see it as more of a dispersed super site where you've got a number of sites that already exist, developing the capability to ground truth particular observations? I understand you didn't do this. I'm just pressing.
Yeah, good question.
Well, my take on that section was more about having a network of super sites.
Yeah.
Maybe like 8 of them. I don't know. I'm just making up that number. But my primary focus on that recommendation was very simple. It's not cheap to do research in the Arctic. And so I don't know why each discipline should build their own site. Why not pull the funding for that infrastructure, like Lesley was saying? So yeah, I think that would be a great topic to flesh out going forward.
Yeah. And I would just say, I mean, from my perspective, I would also argue for, you know, I understand we can't have tons of super sites, but it's a somewhat larger network than a single one, because I think you do have, particularly for things like carbon and for ecosystems that a lot of us work in, there's so much heterogeneity that really, you know, Summit, while it's great for certain things, probably doesn't get you everything you need. So even a handful of sites, I think, would be incredibly valuable. But yeah, a lot more.
Yeah, I mean, you could just imagine people doing vegetation and wildfires, for instance. They wouldn't be too excited about a Summit site.
Yeah.
You know, where there's not vegetation nor wildfires. So
yeah.
It would take at least a suite of these sites.
Yeah. And the other challenge that we always have with sites is that, you know, Alaska, Canada are often better observed than places like Siberia, but there's a lot of land mass over there. There's a lot of carbon over there, and so trying to figure out what we do about that, how we observe that. I certainly don't have the answer to it, but it's going to be a recurring theme as long as we've got that distribution of surface sites that we have now.
Great, thanks.
Okay, anybody else, or should I'll turn it back over to Meredith.
Okay, thanks, Mike. Well, we're at the top of the hour now, and I will post this recording on our website within the next week or so, along with meeting notes, and feel free to comment with additional questions on that event, and I'll share the link here in the chat. And I think that is everything that I wanted to say. Yeah, I hope everyone has a happy holiday.
Yeah, I'd just like to thank Bryan and Lesley for doing that after all that effort to put it together. It's, one thing to do. So
thank you.
I appreciate it. It was really interesting.
Yeah, and our expertise are the satellites. It's not the what comes next. So
yeah,
we need your help. So we really appreciate you taking the time to listen to us.
Yeah,
that was great.
Yeah, I'll add my thanks. That was a great effort.
Yes, I will comb through and see what kind of action items might come out of this and point those out in the notes and do any follow-up that's needed.
Yeah, thank you.
Sounds good. Thank you guys so much. I can't wait to dig in more to this paper.
Well,
I just downloaded the PBS and it says 247 pages. So.
Yeah.
It's a lot of references.
It's a lot of references.
It's still a lot of text.
It is.
All right.
All right. Happy holidays to everybody. Thanks.
Same to you. Thanks. Bye-bye.
Thank you.
Thanks, bye-bye.
Hi, thanks again.